I've been kind of spoiling the H this winter. Brand new muffler, new tires, tubes, and rims on the back. Changed the oil and filter in it. And I'm probably going to get this pulley rebuilt someday, but anyway, someday. But my next thing I'm going to work on is the hydraulic system on it. It does have a live pump on the distributor here. And like they typically did, they tapped a hole into the old belly pump and run a suction line up to there, and then this comes back and goes up to this kind of, because it had a loader on it when I bought it, and I took that off, and I just kind of made this little holder here for a valve so I could use it for pulling the hay bine around and doing whatever I had to do with hydraulics. But anyway, now I put this is just a universal 12 gallon a minute, I think, like log splitter filter on it. But like the discharge coming out of the valve block there is a 3/4 inch, and then I just put a reducer down to a 1/2 inch pipe, because that's what the return line is that goes down and hooks back into the belly pump. There is a 1/2 inch. Now the problem with that is it has quite a bit of back pressure in this filter. I have a gauge on there, and when it's cold, if you open up the throttle, you'll have almost 100 psi of back pressure there from having that 1/2 inch return line. And also, it's still got the valve inside that old belly pump. And my brother was mowing weeds with it with the rough cutter a couple years ago, and a tree branch or something caught this and pushed it up. And when it did that, it shut off the return line, blew the hydraulic filter up, so hydraulic oil was spraying all over it, got on the muffler, and set the tractor on fire. So I'd care not to have that repeat again. And also under here is the fill for it. So anyway, there's a couple issues with this hydraulic system that doesn't meet modern standards. Number one, to the best of my knowledge, there's no kind of a pickup screen down there. So, now I couldn't find a solid number on how many gallons a minute that pump was, but from what I found, it couldn't be more than 10. So I got this intake screen right here that's good for up to 10 gallons a minute, I think they say. And so my plan is I'm going to take this whole old belly pump assembly out of here, and I'm going to make an actual steel reservoir out of 1/8 inch thick steel. And I'm going to have that pickup screen on this line here, and then the return line is going to be a full 3/4 or 1 inch return line going into there. And I know a lot of people just run the return line back into the fill. That's not a good idea. You should have the return below the level of the hydraulic fluid, because otherwise when you have it splashing back in, you're likely to get air entrapped in the oil, which is not exactly a good thing. So I took that little plate off there, and next I'm going to drop what's left of the old belly pump out. I got all the lines unhooked, and it's just 4 bolts, and put a floor jack and a couple blocks of wood under it. You can lower it right out of there. So I'm going to get that done. Almost forgot, you got to unscrew all 3 of these pipe things and take the handle off too before you can get it to drop down out of there. Here's the unit dropped out, and now got the whole belly open there. And so I got a piece of 1/8 inch sheet metal. I've kind of laid out what I got sketched up here for a design. And if my memory serves me correctly, a cubic foot is 7.48 gallons. And according to my math, this thing should hold just under 6 gallons, which will be a considerable improvement over the old one. So I'm going to cut out the outline. And since this is the right side, this is the bottom, and this is the left side, and I don't have any way to really bend this accurately, I'm going to just take the grinder or the cutting disc and score right along that line where I want to bend it, and then bend it, and weld the line to build strength up. That way I don't need to worry about it leaking at the weld. But anyway, I'm going to get the cutoff disc on the grinder and cut this guy out. Okay, here I am a couple cutoff wheels later. Here's what I had marked out on there. Well, that worked out better than I expected it to. Here's the first half of it, folded up, and I spotted it together. Corners bent perfect. So, feeling good about it so far. So now I need to make the other piece. Okay, I got this other end welded in and ground smooth, so it just looks exactly like the corners that I bent. So once it's painted, it'll have a nice smooth corners all the way around. And this is going to be the return. I slid it up in there and traced a hole where the return should come in. And so this is going to be cut in and welded in there. I got this piece of pipe that's going to be inside, and that's going to bring the return down to about an inch and a half from the bottom. That way the fluid returns below the surface to try to avoid any air getting entrapped in the oil. And then it turns out black steel over an inch is kind of hard to find. It was just a fluke that they had this 2-inch black steel coupling that somebody had bought and returned. So what I'm going to do is I'm going to put it in the vise and cut it in half with the grinder, and cut a hole in the reservoir there and stick it through the sides so it's about like this, and then weld this in there. And then I have a port for my strainer to come out of. Now the strainer is for an 1.5-inch hole, and like I say, the biggest they stock is 1 inch, and it was just a fluke they had this one in the shelf that somebody had special ordered and returned. So I bought a 2-inch to 1.5 galvanized reducing bushing. Now using galvanized on a hydraulic system is a no-no. There's the chance that the galvanization could chip off and float in the fluid, and there's a chemical reaction that can take place between the fluid and the galvanization. Now this is a pretty small galvanized piece, and I think what I'm going to do is galvanizing is just a surface coating, so I'm going to take the die grinder and go in there, and I'm just going to clean out the hole inside here and grind all the galvanization off and clean it up and put it together. But I think that should work out alright. Another thing that will help, since I really wish I'd been able to get an 1.5-inch one, so I don't have this kind of hokey setup here with this threading into there, but you do what you got to do. And like I say, eventually I'll plan on building another one of these to put into my M, and when I do that, I'll use the other half of that 2-inch piece, because the screen I got for the M is good for up to 25 gallons a minute, and it is substantially larger and takes a 2-inch opening, so I guess it'll sort of work out in the end. But anyway, so I'm going to cut these holes and get the pipes welded in there, and for the fill neck I'm going to take just a 3/4 black female, cut it right in half with the angle grinder and do the same thing, cut a hole in it this size and weld it in basically flush with the shoulder. And then, so it should all work out with the filler coming through the original filler hole. The return line will come in this hole right here. I'm going to take my filter here and remount the filter with an elbow up so it sits right in here next to the starter, out of the way of the belt pulley, because I still do flat belt with this thing. And then the advantage of having it up here, at first I thought about tucking it down here alongside the reservoir, but then you're running into the danger of maybe catching it on something, and also you wouldn't be able to change the filter without the hydraulic oil running out, since you're below the level. By putting it up here, you can change the filter without losing a crap load of hydraulic oil. And I think for now I'm just going to leave the valve mounted up on that pedestal. Maybe someday, if I get ambitious, I'll build some kind of a bracket here and hold the valve in here and run a rod up through there like it originally was, but I won't worry about that now. Just with what I'm doing, I'm going to more or less bring the hydraulic system closer to modern standards. Okay, here's kind of a preliminary test fit of it. And I drew a line with a Sharpie on it right there. That's 5 inches up from the base of the pan, so I have a parallel line to make sure I have it sitting level in the tractor. And then I kind of just tack that in, and I got to move the hole down just a hair to get that to line up. And right there you can see the back corner of it. I'm mounting it a little lower in the tractor, then I could sneak it up in there just a hair, but I don't want to have any issues with clearances with the drive shaft. Like, that's why it's got that L-shaped profile to it, because the original belly pump was only 10 inches long, and this pan is 15 inches long total. And then it goes up and takes a step back 5 inches, so the front of it's the original 10 inches, but then I got the extra 5 inches of capacity back here. And you gotta have that L there for the coupling and the drive line back there. So anyway, that's how it's gonna look. I don't think it hangs down too terrible far. The original belly pump goes down 5 1/4 inches, and this thing goes down 5, so it's actually just a hair higher than the lowest dip of the original belly pump, and it's still higher than the drawbar is, and only slightly lower than the engine oil pan. So, okay, I just welded in a 1/2 inch for a plug on the bottom. Here's my 2-inch opening for that pickup screen to go in, and here's the fill hole, and here's the return line. Had to get a little creative there to get it to line up with the hole, but anyway, I got the top all welded onto it, so I'm gonna plug all the holes in it except for one. I'm gonna put a 1/4 inch air fitting in there and hook it up to about 20 pounds of pressure with the air compressor, and then use soapy water over it to test for any leaks. So, time to plug holes. I know I said earlier I was thinking of grinding the galvanization off that 2-inch to 1.5 inch reducer, but well, I got thinking, well, that zinc burns off at somewhere around 800 degrees or something, I think, so just set her on the bed of coals and burn it off. And clean it up with the wire brush and put it together. Be just the same as putting in a black steel one. Well, I was going to make this all one video, but it's going to turn into a 2-part series now. I got it all welded together, but when I was drilling the hole to put the drain plug in the bottom, the drill bit caught, so the drill bit stopped spinning, and the drill began to spin, and broke my hand. So I ain't doing anything for a while. I gotta go in and figure out if I gotta get pins and surgery in it. So anyway.